Welcome to Prince Mathsclinic, the e-learning solution at your pace and time. Good day, viewers, and welcome once again to class. Today, we shall be considering this particular question. And the question reads that 8 wooden poles are to be used for pillars, and the length of the poles form an arithmetic progression. If the second pole is 2 meters and the sixth is 5 meters, we are to give the length of the poles in order. But before I go into the solution, let me explain what an arithmetic progression means. Because if you don't understand what an arithmetic progression means, you will not be able to carry out the particular operation that is required to get the remaining length of the poles. An arithmetic progression, in a simple word, is a set of numbers in order such that the difference between the consecutive term is a constant number. What does this number suggest? It suggests to us that the first number or the first term is 3. The preceding term to 3 is 5, and you will observe that 2 was added to this number 3 to get 5, 2 was added to 5 to get 7, 2 was added to 7 to get 9, and 2 was also added to get what? 11. Therefore, we can say that the numbers, that is the difference between these two terms are called consecutive terms because they appear one after the other. Therefore, these numbers here are called the common difference because they are the difference between the first and the second and the third and the fourth and the fifth in this case. Now, let's now apply the knowledge of this in deriving a formula. Therefore, we can say that to get the nth term of any arithmetic progression, it will be the first term plus the number of terms that we want. Let us call that term n. You subtract 1, then you multiply by the common difference. If the second pole is 2 meters, so it means that here our n is 2. We don't know our first term, so we write a. Then the second means what? 2, which is n is 2. 2 minus 1 is 1. Then, therefore, 1 times d. Also, we don't know d. 1 times d is still what? D. So, we're told that the second term is what? Is 2. So, we can put this to be what? 2. So, therefore, I will call this my equation 1. Also, the sixth term is 5. So, using the same formula, my a is what? We don't know. Then, sixth term means 6 minus 1, which is 5. Then 5 times d will give us what? 5d. Then the sixth term is what? 5, right? Meters. So this is equation 2. Now that we have obtained 2 equations, we can go ahead to solve this, right? Using any of the methods for solving simultaneous equation. Therefore, I will advise that you click on the description of this video to find the link to the videos that you've made concerning solving simultaneous equations. So this becomes a minus a will give you 0, 5d minus d will give you 4d, and 5 minus 2 will give you 3. Therefore, if I divide both sides by 4 will cancel 4. Therefore, my d will become 3 over 4. That is my common difference. Now, I want to find my value for a, which is my first pole or my first term. Now I want to substitute 3 over 4. Put it in equation 1. So anywhere I see D, I'm going to put 3 over 4. So this becomes A plus 3 over 4 equal to 2. Now I want to push this here. If it crosses, it turns to negative. So I'll rub this off. This becomes 2 minus 3 over 4. Remember, this can be written as 2 over 1. So to solve this using the butterfly method, remember, 4 times 2 is 8, minus 1 times 3 is 3, then 1 times 4 is 4. So we can say 8 minus 3 is 5, then over 4. That is my A is equals to 3 over 4, and D is 5 over 4. So these are the two values we will be needing to find all the other lengths of the post. Now, since our value for the first term and the common difference has been known, we want to obtain the other values. And mind you, the question has given us the length of the second and the sixth pole. So we want to find out the length of the first pole. And the first pole is just our A. Therefore, we can say our T1, which is what? A is what? 3 over 4 meters. T2, our second term, which is the second pole, 2 meters. Third pole, A is what? 3 over 4 plus, since our n is 3, just say 3 minus 1, you get 2. Then your common difference is what? 5 over 4. 10 over 4. The denominators are the same, so we can add our numerators. So this becomes 13 over 4. So our 13 over 4 is the same thing as saying 3 whole number 1 over 4 meters. Then our fourth term, which is the fourth pole, is also 3 over 4 plus 3 multiplied by 5 over 4, which in turn give us 3 over 4 plus 3 times 5, 15 over 4. If you add 3 to 15, you get 18, then divided by 4. So 18 in 4 will give us what? 4. Remainder 2 over 4. 2 can go in 4, 1 over 2 times. So this becomes 4 whole number, 1 over 2 meters. Then we have been given, the fifth term will be 3 over 4 plus 4 into 5 over 4. So 4 we cancel 4. So you have 5 here, right? Plus 3 over 4. So this will be 5 whole number, 3 over 4 meters. Then we have been given our sixth pole, right? So let's look for the seventh pole. Seventh pole is 3 over 4 plus 6 times 5 over 4. So this becomes 3 over 4 plus 6 times 5 is 30 over 4, which is what? 3 plus 30, 33 over 4. Then the eighth pole is 3 over 4 plus 7 times 5 over 4. So which is 3 over 4 plus 35 over 4. 3 plus 35 is 38 over 4. And 4 can go in 38 in 9. 4 times 9 is 36. remainder 2 over 4. 2 can go here, 1. Sorry, 2. So this becomes 9 whole number, 1 over 2, right? Meters. Let's consider another question. But this time around, we shall be looking at the question that relates with geometric progression. By way of providing background information to geometric progression, a geometric progression is simply a set of numbers in order such that the difference between two consecutive terms is a multiple, right? And that difference between the term in geometric progression is referred to as common ratio, right? Remember, the common ratio is a common multiple that spreads, that is differentiating a term from the other, right? For instance, if I have numbers like this, 2, 6, 18, and so on and so forth. Now, what is the common ratio here? If I say 6 divided by 2, I will get 3. If I say 18 divided by 6, I will get 3. So this 3 is the common ratio, right? And from here, we can generate a formula that says my Tn is what? The first term multiplied by the common ratio to the power of n minus 1, such that n is the number of terms we are dealing with. First term, R is my common ratio. Good. So this formula will be useful for us in solving this particular question. Let's look at the question. The third and fifth terms of a geometric progression are 9 over 2 and 81 over 8 respectively. We are to find the common ratio and the first term. So let's pick the data. The third and the what? Fifth term. So for third term, where n is 3, it will be first term, which is a, right? The common ratio. Then n is 3, y minus 1. And 3 minus 1 is what? 2. We're told that the third term is what? Is 9 over 2. 9 divided by 2. Then the fifth term, n is 5. So repeat again. First term, common ratio, then this will be 5 minus 1. And 5 minus 1 is what? 4. Equal to what? 81 over 8. Let's call this equation 1. And let's call this equation 2. So in order for us to obtain our values for R, let me divide equation 2 with equation 1. So it will look like this: AR to the power of 4 divided by AR to the power of 2. Then we have 81 over 8 divided by 9 over 2. Interestingly, applying the laws of indices, we know that when a particular base carries the same power under division, the power in the numerator would subtract the power in the denominator. So this is 1 and 1. So 1 minus 1 is 0, and a to the power of 0 is 1. Or better still, just cancel the a. Then here, r to the power of 4 means r 4 times, over r square means r 2 times. One r will cancel one r. This r cancels this. You have just r times r left, which is r squared. Or you can use the laws of indices to say r to the power of 4. Division means subtraction. So the power in the numerator will subtract the power in the denominator. So 4 minus 2 is what? 2. So you can say arrow squared equal to, now when division turns to multiplication, right? The second term would what? Will be inversed such that what? My denominator becomes my numerator becomes my denominator under multiplication. Therefore, 9 can go in 81 9 times, 2 can go in 8 4 times. So I have my arrow squared to become what? 9 over 4. And if I choose to take the square root of both sides, remember in square root you have to put a plus and a minus because it could be that positive or negative. In this particular aspect, my square will cancel my square root. Therefore, my arrow will now be plus or minus square root of 9 over 4. Hence, my common ratio is now plus or minus. You can write this square root of 9 over 4 as square root of 9 over square root of 4. And square root of 9 is what? 3. And square root of 4 is what? 2. So your common ratios are either plus or minus 3 over 2. Good. That's the A part. Now, to get my first term, put 3 over 2 for arrow into equation 1. Therefore, A, now instead of writing arrow now, since I've said let this replace this, it's going to be 3 over 2 squared over what? 9 over 2. Sorry, 3 over 2 squared equals to 9 over 2. 3 squared means 9, 2 squared means 4, equals to 9 over 2. So to get my A, I have to divide both sides by 9 over 4 and divide here as well by 9 over 4. 9 over 4 here cancels out 9 over 4 here. So my A becomes what? 9 over 2. Then when divide turns to multiplication, denominator becomes numerator becomes denominator. So this becomes 4 over 9. 9 will cancel 9, and 2 here 1, 2 here 2. Therefore, my first term is what? 2. And that is the second question. I hope the solutions is helpful. Kindly click on the notification icon so that you can get to see useful videos like one you have just watched, and also share this video to your friends and loved ones. Thank you. Bye.